Moving on to the next one, let's take question number 63. fx and gx are two polynomial functions such that their derivatives till third order are all 0, and fourth derivatives of f and g, when you add together, the value is equal to 0 as given. That's clear? Now, limit x approaching to 0, limit n approaching to infinity, fx to the power 2n upon gx to the power 2n is required. Now, how to start this question? Let's understand. You can write it as limit n approaching to infinity, limit x approaching to 0, fx by gx whole to the power 2n. That's clear? Now, n is approaching to infinity. fx upon gx, it is 0 by 0 form. Apply L'Hopital. First derivative again 0, second derivative again 0, third again 0 by 0, fourth when you move on. Applying L'Hopital again and again. What we obtain? We obtain limit n approaching to infinity, limit x approaching to 0, f fourth derivative divided by g fourth derivative whole to the power 2n. Now this value is equal to -1 because you know that fourth derivative of f plus fourth derivative of g is equal to 0. So obviously this value is -1. Whole to the power 2n makes it equal to 1. So the correct answer for this question is 1, that is option number 3. I'm sure this question is clear. How we get the value 1? Let's move on to the next question of this paper. So let's consider question number 64. If limit x approaching to pi by 4 plus this term is a to the power -3 by 2a, then a possible value of a is. Let's try this one. Here you can see sin x minus cos x is definitely positive when x is approaching to pi by 4 from the positive side, right? Similarly, tan x is greater than cot x, so this value is also positive. I can read this thing as limit x approaching to pi by 4 plus root sin x minus cos x divided by root of sin square x minus cos square x divided by sin x cos x. That's clear? Now here you can simply say this is equal to limit x approaching to pi by 4 plus root of sin x into cos x divided by sin x plus cos x, right? Now this is given to us as, you can see in this question, a to the power -3 by 2a. Now writing this is equal to a to the power -3 by 2a. Substitute the limit over here, you obtain sin pi by 4 cos pi by 4, that means 1 by root 2 into 1 by root 2, it's a square root, so it is 1 by root 2 multiplied with. In denominator you have sin x plus cos x, so 1 by root 2 plus 1 by root 2, that is root 2. So square root of root 2, that is to the power half, you can say, is equal to a to the power -3 by 2a. So here you have 2 raised to the power -3 by 4 is equal to a to the power -3 by 2a. Now when you can compare here, you obtain that one of the possible values of a is equal to clearly 2. So let's check out from the given options because it was given as 2. So let's consider this one as one of the possible values. Let's move on to the next question now. The left hand derivative of the given function fx equals this one at x equals 2n plus 5 by 4 is. So let's try this question. It says fx is equal to x greatest integer sin pi x into cos pi x, correct? Now When you consider around the point 2n plus 5 by 4, let's do one thing. 2n plus 5 by 4 meaning 2n plus 1 plus 1 by 4. So let's consider a very small interval for the sake of simplicity, 2n plus 1 to 2n plus 3 by 2, open interval. Now when you put here for x as 2n plus 1, you observe sine pi into 2n plus 1, cos pi into 2n plus 1. When you put 3 by 2, so what is the resultant over there? You can see that this is lying in third quadrant. In third quadrant, both sine and cos are taking values between -1 and 0. So what is going to be the greatest integer? It is simply -1 for each case. The value comes as simply fx is equal to x when I have taken a small interval x as 2n plus 1 to 2n plus 3 by 2. I have taken this interval because the value 2n plus 5 by 4 is lying in this interval. So what is the derivative throughout this interval? It's simply 1. So f dash x is equal to 1 for this small interval. So let's check out from the given options. Correct answer is option number 3. I'm sure this question is clear. Let's consider the next one.